The unit circle and its radian measures. We have already gone ahead and labeled our unit circle in degree measures. And if you haven't seen that video, please go back and figure out or discover how we came up with these special angle measures. But we start on our positive x-axis and we rotate counterclockwise until we get wherever it is we need to go, and that represents our angle of rotation. So we labeled all of these degree measures, and then we talked about what a radian measure is. Okay, and we know that one full rotation or one revolution is equivalent to 2 pi radians, which means that, of course, half of a revolution is pi radians. And then we went ahead and talked about converting our degree measures into radians. And then, of course, we could go in reverse and take our radian measures and turn them back into degree measures. So let's do a couple of practice problems using these special angles on our unit circle. And I think on our last video, we focused mainly in quadrant 1. So now let's move on to other quadrants. So if we start on our positive x-axis and we rotate counterclockwise, let's go to, 150 degrees, okay? Way up here. So we start on our positive x-axis and we rotate 150 degrees. So we'll take that 150 and we're going to multiply by pi radians over 180 degrees. And again, when you multiply fractions, you just go straight across. So if you would like to turn this 150 degrees into a fraction by dividing by 1, go right ahead. So when we multiply, we do this dimensional analysis, and we see that we can reduce our degree symbols. Degrees over degrees reduces. And then 150 and 180 are both divisible by 10. And then 15 and 18 are both divisible by the number 3. So 15 divided by 3 gives me 5. 18 divided by 3 gives me a 6. So now when we multiply, we have simplified or reduced before multiplying, and it makes life a little bit easier. We end up with 5 pi 6 radians. So 150 degrees is equivalent to 5 pi 6 radians. All right, let's do another one. Maybe let's go into quadrant 3 now. So again, I start on my positive x-axis and I rotate counterclockwise, and let's go down to 225 degrees. So we start here and we rotate counterclockwise. So 225 degrees. Again, because we're starting with degrees, we'll multiply by pi over 180 degrees. And we'll go ahead and turn that into a fraction also. And let's see what reduces. Our dimensional analysis shows us that we can reduce our degree measures, and we're left with this 225 over 180. So you might recognize that this ends in a 5 and this ends in a 0, so both of them are divisible by 5. You might also, depending on how great you are at your multiplication facts, see that they're both divisible by 45. You can use your calculator. However you want to reduce is fine. But I know that 225 degrees is divisible by 45. I can reduce that and it turns into a 5. And 180 divided by 45 is a 4. So our 225 degrees is equivalent to 5 pi 4ths radians. So I'm going to go ahead and label this up here, 5 pi 4ths radians. And you can do that for every single degree measure on our unit circle. You can do it for any degree measure, whether it's on your unit circle, labeled on your unit circle or not. It's fine. But that's what I want you to do right now. Go ahead and pause the video, and I want you to convert every single one of these degree measures around our unit circle, convert those into radians, and then let me show you what the equivalent values are. All right, here we go. So here we have labeled every single special degree measure and its equivalent radian measure on our unit circle. And I want you to see if you can notice some of the patterns that we have here. So we've got our positive x-axis here. And if you look at all of, let's start with this kind of bluish color, all of the radian measures that have a denominator of 6, if you look at all of those values, let's see, if I start here and I rotate, From my x-axis until this angle of rotation, that's a 30-degree, what we call a reference angle. If I go over here into quadrant 2 and I rotate to the closest x-axis, I can see the angle measure right here that's created is also 30 degrees. If I go just below and I rotate backwards, again, this reference angle is also 30 degrees. All four of these measures give us a 30-degree reference angle. Okay, a reference angle is just the degree measure between the angle of rotation and the x-axis, the closest x-axis. Okay, so these patterns pop up and they'll kind of help you to see or remember where all of these radian and degree measures are located. And the same kind of patterns are going to pop up and be true for all of these purple radian measures right here. Their denominator is a 4, which is going to tell us that its reference angle is always going to be a 45 degree no matter which quadrant we're in. Then you can look at these yellow, highlighted yellow radian measures. Their denominators are all a 3, and those reference angles are always going to create 60 degrees. And again, you don't have to memorize that. The more that you work with the unit circle, the more likely you are to remember them off the top of your head, but it's not necessary. You can always convert using the formulas that we've already talked about. But again, if you like memorizing, if that's what you're into, go right on ahead and you can memorize your unit circle until your heart is content.